We've now taken a look at a general overview of the 3D scanners as well as the Sense scanner. So let's jump into the NextEngine and its software. Now the NextEngine is a desktop scanner. It's a very high resolution, high-end scanner, and it utilizes two softwares. The Scan Studio is the actual software that we will do the scanning and aligning and output in. And then Rapidworks is a complementary software that can be purchased for a few $1,000s to go with it, that will enable us to take a scan or even an STL and import it, and then reverse engineer that STL into a series of features that can be imported into something like SolidWorks or Creo and can be built upon. As an STL stands, or a scan itself stands, there is no true geometry that a CAD software can pick up. So something like Rapidworks is incredibly powerful. It is also incredibly complex. So it's almost like a CAD software in and of itself to learn. So I am going to provide an introduction to it, but not really elaborate too much in this video. So we're launching the NextEngine Scan Studio software. And what we're going to scan is actually this, let's say this is a 3rd century, incredibly rare museum piece that we have graciously been allowed to borrow, and we'd like to scan it for prosperity and to replicate it and to share the model with others. So I'm going to place this on the base. So here's our scanner. And if you notice, if you recall from the general overview, the actual lasers are in there. And then here's the base, and it has a pedestal on it. And I'm going to place our model right there on it. And if you notice, we're going to ensure that it's going to be, I have a ruler here to ensure that it's at a particular distance, and we'll confirm that distance as we jump into the settings of the software. So this is kind of a introductory screen showing a visual of what the scan might look like. But we're going to jump into scan, and we're going to select some settings for it. So we see our item to be scanned. First and foremost, positioning. Do we want a single panel? And what that would really be is almost just a 2-dimensional image. Just the scanner would hit it once and be done. So you wouldn't get a lot of topography information. This might be good to collect a little additional data once you have done something more comprehensive like the 360 panel. Now the 360 panel would be taking a series of 2-dimensional topographies and meshing them together. And the machine automatically does that, which is very, very powerful, and it facilitates a great deal for us as users. The bracket is 3 panels that are taken at 45-degree increments. So in total, they overlap to about 90 degrees. And it's quite nice to pick up additional data once you've done maybe one entire 360 loop for, let's say, the vertical orientation. And then we might turn, in this case, our monk statue in the horizontal and do a 360. And we could merge those two entire panels. And if there's any data that we have not yet captured in that scan, we might consider doing a bracket or a single to pick that information up. And I'll hopefully try to clarify what that means as we get further into this video. Now, with this 360 paneling, we can call out how many panels we want to create, either by creating 4, so essentially at 90-degree increments, all the way up to 16. 16 would be capturing, every 20 degrees, a very, very comprehensive scan. Now that is probably overkill. And that also is alarming in terms of, if you notice down here, the time and the memory requirements based on the information that we're putting into the scan itself. So if we only did 4 divisions, notice that would take about a little over 5 minutes, and it would only require 9% of the memory. If we bump that all the way up to 16, it would take upwards of 20 minutes, and it would require almost 40% of our memory. So far and away, the manufacturer recommends anywhere from 4 to 7. You may go a little bit more if you have a really complex model, but let's go ahead and go with 7, and we should be fine there. Next, the amount of data that we're collecting, the points per square inch. So if we were to just have it standard definition, that would give us kind of a generic point cloud. If we wanted to do just a really quick and easy, we could turn it down to quick. And if you notice, it would require almost virtually no memory, and it would require very little time. If we were to ask it to produce a high definition point cloud, it again bumps it back up into the plus 20 minute, and we'd essentially almost max out our memory. That point cloud would be enormous. So for the sake of this video, and also that this isn't an overly complex model, we're going to go with just, let's say, standard definition. The recommendation is standard or 1 or 2 notches higher than that for most scans. Now this model is light bordering on neutral. It kind of has a beigeish hue to it. If you are familiar with scanning, the lighter the object, the easier it is to pick up. Things like dark hair and high gloss metal or black sheen, very difficult to pick up. So we definitely want it to be neutral or light. If we did have, let's say, a black object, we do have talcum powder. Some firms will even hit it with primer to just put a kind of a temporary lighter coat on it. We also have white pens that we can mark things up to give it that lighter color that will refract easier. So stick with neutral. And then range is what I mentioned, why we have the ruler out, is depending on the size of our model, we want the actual scanner assembly to be set at a particular distance from it. So right now, macro, which to me is a little deceptive in its name, this is actually more micros, because this is the closest to the model that the scanner will be. And in this setting, the recommendation is 6.5 inches to no more than 9. The ideal is right there at about 7.5 to 8 inches. So that would be macro. If we started pulling back to, like, let's say wide, you're going to see that it kind of threw our field back. And this is closer to 17 inches to 22 inches back. And if we went to extended, so let's say we want to scan like a bumper or a car door, something much, much bigger, we could step back to gain a much broader perspective of the object. Because of this, the small size of our model and the desire to get high detail, we're going to keep it in this macro setting. And so I'm going to confirm that we actually can move this a little bit closer to get it to about the 6.5 inches. And that's pretty good right there. And if we wanted to, we also could move the, we could move it up a little bit so that it's just better in line. There we go. Okay. And then lastly, to test this out, what we could do is we could start rotating it to make sure that it's right on the center of axis. And so it doesn't rotate out of our field as it's paneling for the screens. So yes, we like that. This is every single panel, this little icon. This one is kind of a continuous turn. So And we pretty much can start the scan at any of those orientations. So as we see it, as things currently stand, it's 9 minutes and it would be 7% memory. So let's go ahead and start this. I hit the start button, and as you notice, it's starting to, right here, scan 1 of 7. It's capturing that 2D information, so that single panel. And what will happen is each of those panels will then be aggregately combined down here. So when all is said and done, we're going to have 7 2D panels in this culmination panel A. Okay, so I want to show you, as the scanner hits our part, you see that it actually is hitting it with that series of lasers, and in the background we can see it on the panel back there. But it's refracting and essentially creating the topography as it moves those lasers along our part. So this is scan 1 in process. And if you notice, it now has generated that. It's going to process that scan 1. And there is our first scan of the 7 panels. So if you notice, it's truly just one flat kind of capture of topography. And then it will obviously do the remaining 360 degrees. Now, when we look at that, we have some different modes of visibility that we can use. This is in full color. And the other options are, this is what's called shaded. This is more of like a, almost like a netting or like a shrink wrap around the model itself. In addition to that, I'll expand this again. I just don't know if my projector is showing up and blocking this information for you good people. But this is our triangulation. So if you notice, right now there's only one layer, kind of one mesh of triangulation across this. That's because there's only been one scan. As we get multiple scans, there might be overlap of these triangulations where multiple scans have caught the same information. And that would be the redundancy that causes this point cloud to be much larger in file size. We also can see that in the true point cloud. Here is the point cloud option. So this data, again, as the files, or excuse me, as the scans, the panels overlap, we're going to see kind of those point clouds potentially have overlap or redundancy as well. So I want to just complete the second scan in this particular video, and then we'll jump ahead, because what will happen is, I'm going back into the full color option. We're going to get that 360-degree panel in the vertical orientation. That will all be done for us, automated through the system. We then will turn our model on its side to capture the information that we don't get. Okay, so there you see that we're starting to get, that's the second panel captured in there. So we're starting to get a little more of that true 360 topography. And if you notice down here, here they are. This is scan 1 and scan 2. And when all is said and done, we'll have all 7 of them here. Once we have those 7, we'll want to orient our model and take another series of 360 panel scans that will automatically be combined in the system, but then we need to manually take those two and combine them together so that we get all the data into a single file. So now that we are moving on from those first 2 scans, I'm going to go ahead and stop this video, and we'll jump back in once we've gotten the second scan series.